Hey everyone. So, if you work with APIs, you definitely know that feeling of relief when you hit send and see that beautiful 200 OK pop up. But is that really enough? Today, we're going to dive into how you can automate your API health checks right inside Postman. We'll use some simple scripts to make absolutely sure your APIs are fast, reliable, and correct every single time. You know the drill. You send a request, you get that 200 OK back. High five, success, right? Well, maybe. See, just getting a response doesn't tell you the whole story. Is it the right data? Did it get back to you fast enough? And maybe most importantly, will it still work the next 100 times you call it? That's the real problem we're here to solve. For a long time, the process was pretty painful and manual, right? You click send, you kind of squint at the JSON response, and then you move on. But that whole approach is slow. And it's so easy to make a mistake. You might miss a tiny bug one day that you happen to catch the next. Automation is the complete opposite. It is lightning fast, it's totally reliable, and it's perfectly repeatable day in and day out. So, how do we get this magical automation? Well, the answer is Postman's test scripts. These are just small but, trust me, mighty pieces of code that do all of that heavy lifting for us. They turn our manual spot checks into this powerful automated safety net for our APIs. Okay, so what is a test script really? It's just a little snippet of JavaScript that you attach to any request in Postman. Now, the most important part here is the timing. It runs after Postman gets the response from the server. This is key because it lets your script look at everything about that response. The status code, the headers, the body, all of it. And this right here, this is the basic building block for every single test you'll write in Postman. It all starts with pm.test. The first part, the text in quotes, is just a plain English description of what you're checking. This is going to be your best friend when a test fails and you need to know why. The second part is a function, and that's where you'll write the actual logic that checks if the response is good or not. All right, let's get practical. We're going to build what I like to call our core test toolkit. These are the foundational checks you should probably add to almost any API request to make sure it's not just working, but that it's actually healthy. First up, the most basic, but honestly, the most important check of them all, the HTTP status code. Before you even think about looking at the data, you need to know if the request was successful, if something was created, or maybe even if it failed in the exact way you expected it to. Think of this as your first line of defense.
And here's the code to do it. It's almost like reading a sentence in English, right? Inside our pm.test function, we just write pm.response.to.halfstatus 200. We're literally just telling Postman, hey, I expect the response object I just got to have a status code of 200. It's that simple, but it's incredibly powerful.
Now, an API that gives the right answer can still be a bad API if it's super slow. Performance really is a feature. If your users are waiting seconds for something to happen, from their point of view, your API is broken. So our second essential check is all about speed. This little bit of code sets a performance benchmark. We use pm.expect to look at the pm.response.response time. Then we just chain on to.be below 500. This is our assertion that the total time from the moment we sent the request to the moment we got the full reply back has to be less than 500 milliseconds. And of course, you can change that number to whatever your goal is. Okay, so our request was successful and it was fast. Great. Now it's time to actually look inside the box. We need to check the data payload itself to make sure we got back exactly what we were expecting. Here's a super common example. First, you can see we're creating a variable called JSON data, and we're using pm.response.json to parse the response text into a JavaScript object we can actually work with. Once we have that, we can start checking things. The next line, pm.expect.json.name.to.eql does exactly what it says. It checks that the name property inside our data is equal to John Doe. So we've gotten pretty good at testing individual requests. But let's be honest, real-world apps aren't just single, isolated calls. They're complex workflows. So now it's time for the power move, chaining our requests together, where the output from one API call becomes the input for the next one. It's really just a simple three-step dance. First, you store a value from a response, like a new user's ID or an authentication token, and you save it into an environment variable. Second, you use that variable in your next request, usually right in the URL. And finally, if you need to, you can always retrieve that value in a later script. Store it, use it, retrieve it.
All right, let's put all of these pieces together and see what it looks like in a real-world scenario. We're going to build a complete test for a classic user workflow. We're going to create, read, update, and then delete a user.
Everything has to start somewhere. For us, our first request in the chain is a post call to a /users endpoint. Its only job is to create a brand new user in our system.
Now, in the test script for this create request, we're doing two super important things. First, we'd have a test for a 201 created status to confirm it worked. Then, and this is the magic part, we parse the response, we grab the ID of that new user, and we use pm.environment.set to set it to a variable we're calling user ID. This ID is the golden ticket that's going to unlock the rest of our workflow.
Now that we have that user ID saved safely in a variable, we have the key we need to interact with that specific user. We're going to use it to build out the rest of our chain. We'll fetch that user, update some of their details, and finally, clean up after ourselves by deleting them. And this is exactly how we use that user ID variable in the URLs for our next requests, the get, the put, and the delete. We just use this double curly brace syntax, WID. Postman sees that and automatically swaps in the actual ID we saved a moment ago. This makes sure that all of our actions are happening on the exact same user, creating a perfect, self-contained test from start to finish.
Whew, we have covered a lot of ground, from the simplest assertions all the way to chained workflows. So let's just boil it all down into a quick takeaway cheat sheet to help you get started writing some really solid API tests.
Just try to remember these 4 pillars. Use assertions to make sure the response is correct. Use response time checks for performance. Use chaining to build realistic multi-step user workflows. And when things go wrong, and they will, use debugging with console.log to see exactly what the API is sending back.
And finally, here are a few pro tips that will make your life way easier. Always name your tests with clear descriptions. It makes the report so much easier to read. Group related tests together in Postman collections so you can run them all with one click. Use environments to easily switch between your dev, QA, and production servers. And a big one, always try to clear your environment variables after a test run so you don't have old data leaking into your next test.
You know, automating these kinds of checks isn't really about testing code. It's about building a safety net. It's about giving yourself and your team the confidence to develop faster and ship more reliable products. So the question I'll leave you with is this: what's the first critical workflow in your application that you're going to automate?